Everywhere B bar is uniform, gravity is present, the surface is rough. So first what will happen to this charge particle is going to move in a spiral path with increasing pitch. Is going to move in a spiral path with increasing pitch. What will be the radius of that? Will be a constant, will be a fixed value. So this will be the axis. Let me give the, this will be the axis. So here the charge particle, let it be projected. So then it's going to move in a spiral path. So there's a diagram I'm giving. So look at the B bar velocity. So I'll make B bar upward. So it's going to move in a spiral path. I have to draw the diagram. I'll take some reference lines. It'll be easy for me to draw. There's a charge particle. Let's come for this one. This charge particle is going to so what should happen to the radius? The radius of that, like this, it is going to revolve and it will strike. It will strike the ground. Let's assume something. So because of gravity, it will have increasing pitch. If you calculate the pitch, no, this is P1, P2, not increasing pitch. I'll modify the diagram. So increasing pitch. Okay, see, no, the pitch is increasing. So you take this is P1, this is P2. So P2 greater than P1. Why? Because of acceleration. The velocity will be somewhere, if you take that one, along y-axis, the velocity will be continuously increasing. And what will happen to the speed of particle in xz plane? So if you define this as coordinate axis, in xz plane, it is going to revolve in a circular path. And along y-axis, the velocity will continuously increase. So what is Vxz should be equal to V naught. So therefore, what will be the radius of circular path? If you calculate the radius of circular path depends upon the speed of particle in xz plane. So what is R is equal to M Vxz by QB. Already I discussed such numericals. This one. And velocity along y-axis will be gt. So therefore, it's as it is accelerating, the pitch will continuously increase. So like this, with increasing pitch, constant radius, it's going to move spiral path, then it'll come. So when it comes to the ground, so when it's striking the ground, so on the when it is about to strike the ground, the charge particle will have velocity like this. A component of velocity will be tangential to the ground. Let me write Vxz. It will be easy for you. And the other component will be Vy. So in elastic collision, so after collision, so what will happen to the charge particle? That Vy will become 0. So it will end up with only Vxz. And how is the magnetic field? Then what should be the, and this is a rough. So what should happen to charge particle now? It is going to revolve in a curved path. It's going to revolve in a curved path. Inelastic collision occurs. E equal to 0. Okay, this one. What should happen to the, now we'll look at on the ground. So on the ground, what should be the motion of charge particle? Let me see from the top view. So the top view, how it will be. So this is the velocity of the charged particle. B bar out of the plane. So the magnetic force Vxz, or you can write it equal to V naught. So what is Vxz equal to? This should be equal to V naught, no? So write it V naught. Then the magnetic force will act here. If there were no friction, so what would have been charged particle? It would have completed, it would have been continuously revolving in circular path on the ground because of surface rough. What should be the possible path of the charged particle? What is the possible path of the charged particle? Now just we are introducing a concept of the friction. So this is the velocity V naught, and this everything is what? The ground, in the plane of the ground, and we top view. So shall I put it in spiral path here? So finally it will come to rest, and I'll call this is the O, no? And at O, what will happen? I'm guessing that one. What is O? O, this is the axis of helix, no? Try to, is it possible? Can it have, why the speed should decrease? Because of friction force acting. At all the points, how the FB should be acting. FB should point towards the O. And how the friction should oppose relative motion. Friction should oppose the relative motion. So it will act opposite to velocity, tangential force it will be. So and the speed will decrease. And so you can now make a guess why you are bringing particle to be at rest at O. Everything is what? The ground. I'll write P1. Oh, okay, this is A1, A2, no? So that A1, A2 is what? Okay, you are waving from the top. The charge particle will be like this. Okay, now we have to put, finally it'll come to rest here. So let's go back to the basics here. R equal to m v naught by qb, no? M qb constant. If v naught decreases, R will decrease. So when v naught 0, R should be 0. So what is the radius of this path? At initially it was equal to R, no? Initially it should be equal to R. So finally when v0, R should be 0. So R should be 0 means at the center of curvature only to the initial point. So it should come to rest at the axis of helix only. And what about the frictional force? So somewhere when particle is here, what are the forces that will be acting? Magnetic force, FB. The frictional force, you show like this. Can we calculate what is the path length? What is the time taken? And you know friction, what is the friction? F should be equal to mu mg. So this should be the after collision it is. This is before collision. So like this, some theoretical questions they can bring here. You have to be careful. Any of very arbitrary way of asking questions here. There's a path of particle on the ground. We can also calculate the path length, this red color path. We can also calculate the time taken because we know F equal to mu mg and we have velocity here. So write down the basic kinematics and work out. I think in books available, try to work out few problems related to like this also. Now, can we conserve angular momentum about O? Friction is acting, it will set up a torque, so not possible. Okay, tomorrow we'll see some problems related to F equal to BIL. They're about the charge particle and dipole moment. Tomorrow we'll discuss problems related to the F equal to BIL. Okay, thank you. Any doubts related to this, you can ask me, I'll wait.